Alright, now let us see how to find the joint equation of a pair of lines through origin with given slopes. So that means if we are given the slopes of the two lines to be m1 and m2, then we know that the equations can be written as y equal to m1x and y equal to m2x. But as you know, before writing the joint equation, we must write them in the standard form. So that is m1x minus y equal to 0 and m2x minus y equal to 0. Right? So therefore the joint equation will be the multiplication, that is m1x minus y into m2x minus y equal to 0. So we multiply and collect all the like terms. The x square coefficient will be m1 m2. Then the middle term, that is the xy term, will have minus m1 and minus m2 as you know the terms that will come attached with xy. So taking minus common, we have m1 plus m2 times xy, and lastly the y square term will be positive only. So this is the third form of the equation of a pair of lines through origin in case their slopes are known. So that means, just to summarize, so far we have seen three different ways of describing a pair of lines. Hence the joint equation of a pair of lines passing through origin can be written in three ways. First is the most general form, which we have seen in the beginning. So that is, we can see that it's a homogeneous equation in x and y with the coefficients a, 2h and b. Now the same can be transformed into the second form, which is the auxiliary equation. Alright, now here the terms x and y will not be present directly. So because we have converted the general form into an auxiliary form in which it's a quadratic equation in m. Okay? And the roots of this quadratic equation represent m1 and m2, which are the slopes of the two lines. And if these slopes are directly known to us beforehand, then we use the third form. Okay? In that case, we write the equation as we have just derived. Okay, so while solving the sums based on pair of lines, we can switch from any one form to any other form based on which information is given to us.